All right, number 1, we're finding the limit as x approaches negative infinity. So this is going to be a Bowe-Botten eats RC problem, which means we check the highest degree on top, which is 5. Highest one on bottom is 4. In this case, it is bigger on top, none. So we need to take the entire term on top and the entire term on bottom and put them over each other. X to the 5th over negative 5x to the 4th. And then we reduce. We don't care if there's any numbers going on there, but the negative is important. So we're going to have negative x to the 5th over x to the 4th. So that's 4x's on bottom, 5x's on top. We can cancel all 4 of those with 4 of those, and we're left with just negative x to the 1. Once we reduce it, we come back and we look what we're taking the limit as x approaches. The limit as x approaches negative infinity. So we're going to plug negative infinity in for x. So I'm going to have negative infinity, which gives us positive infinity. Number 2, the limit as x approaches negative 2. That's a constant number. So the first thing I try to do here is try to just plug it in. But negative 2 plus 2 is 0, and that would make me divide by 0. So what I do then is I factor, cancel, try again. Our numerator, we have 2 terms, and if there's 2 terms, then there's 2 ways to factor. The first way is to pull out any greatest common factor you might have. And I can pull out a 3 and x squared from both of those, and it leaves me with an x plus 2. Once you pull out the greatest common factor, you look to see if there's the difference of 2 squares. Difference means subtraction, and we don't have a subtraction, so this is not the difference of 2 squares. So that's as far as we can go on factoring the numerator. The denominator, there's nothing we can do to that. But now we can cancel this, and we're left with 3x squared. So we factored, we canceled, we're going to try again now. So we get 3 times negative 2 squared, which is 3 times 4, which is 12. That's our limit. Number 3, the limit as x approaches negative 2. So the first thing we try to do is plug negative 2 straight on in. So we get 2 minus negative 2, which is 2 plus 2, which is 4. So this can be done. So we're just going to plug it in. So 2 times negative 2 minus 2 over 2 minus negative 2. So this is going to give me negative 4 minus 2 over 2 plus 2 is 4. So that's negative 6 over 4. And that reduces, I could take a 2 out of both. So that's going to be negative 3 over 2. That's my limit. Number 4, we have the limit as x approaches infinity. So this is a Bowe-Botten eats RC problem. So we look for the highest exponent on top and the highest exponent on bottom. In this case, the exponents are the same, so we are going to reduce the coefficients in front. So the coefficient here is negative 8, and here is 4. So negative 8 over 4 gives us a limit of negative 2. Number 5, the limit as x approaches negative 5. The first thing we try to do is plug negative 5 straight on in. So we have negative 5 squared minus 25, which is 25 minus 25, which is 0. That's a problem. So I'm going to factor, cancel, and try again. So in the denominator, I only have 2 terms, and there's 2 ways to factor. First thing is try to pull out a greatest common factor, but there isn't one. So then I look to see if it's the difference of 2 squares, and it is. This is x squared minus 5 squared. So this is going to be x plus 5, x minus 5. And then in the numerator, it's a trinomial, so backward FOIL. X squared is going to be x and x the number in front of the constant is negative. That tells me I have opposite signs. And then factors of 50 are 1 in 50, 2 in 25, 5 in 10. And I need them to add up to give me negative 5. And so I'm going to have it be a positive 5 and a minus 10. Those cancel. So I'm left with x minus 10 over x minus 5. I factored, I canceled. I'm now trying again. So I'll plug in my negative 5. And I get negative 15 over negative 10, which reduces, it's going to make it positive, and I can take a 5 out of both, so that's going to be 3 over 2. And just a reminder, your calculator will nicely reduce it for you if your brain is not working. So on your calculator, if you were to just type this in, boom, boom, if you were to type in negative 15 divided by negative 10, and then go to math, frac, it always will put it back into reduced fraction form for you. So 3 over 2. Number 6, the limit as x approaches negative 3. So first thing I want to try to do is plug negative 3 straight on into the problem. And so if I do that, I'll have negative 3 squared plus negative 3 minus 6. So that's 9 minus 9, which is 0. That doesn't work. So I'm going to need to factor, cancel, and try again. So in the denominator, that one's easier to factor. X squared is x and x. The sign in front of my constant is negative. That tells me I'm going to have opposite signs. One's positive, one's negative. Factors of 6 are 1 and 6 and 2 and 3. I need one positive and one negative, and I need them to add up to be a positive 1. So that's going to have to be this one if I make the 2 a negative and the 3 a positive. Then in the numerator, I don't have a 1 in front, so it's a little bit harder, but not bad. I know 5x squared has to be 5x and x. The number in front of the constant is positive. That tells me I'm going to have the same signs. And if we look over at the other term, that tells me what signs they're going to be. They're going to be positive. So positive and positive. Factors of 3 are only 1 and 3. And since I'm really wanting to cancel something from the bottom, I'm going to hope that the 3 is there and the 1 is there. But I'm not just going to hope and go with it. I'm going to check it real quick. And when you check it, you need to FOIL, but you really only have to do the OI part of the FOIL. So I'm going to do outside is 15x and inside is 1x. And if I add those together, I get 16x, which is what my term was. So I know I did it correctly. So I can cancel those. And I'm left with 5x plus 1 over x minus 2. So I factored, I canceled. Now I'm going to try again to plug my number in. So I'm going to have 5 times negative 3 plus 1 over negative 3 minus 2. So that's negative 15 plus 1 over negative 5. So negative 14 over negative 5, which is 14 over 5. Okay, number 7. The limit as x approaches infinity. So this is going to be a Bobo-Botten type problem. So I look for the highest exponent on top, which is 3, and the highest exponent on bottom, which is 4. And it's bigger on bottom, so that's Bobo. Bigger on bottom, 0. So that limit is 0. Number 8 is also the limit as x is approaching infinity. So I look at the highest degree on top, which is 3, and the highest degree on bottom, which is 2. and this time it is bigger on top, none. So that means I need to take this entire term and this entire term, and I'm going to put those over each other. And we don't care about the actual numbers in front, so we don't care about the 5. That doesn't do anything to be multiplied to infinity. And so I have negative x cubed over x squared. I have 2 x's on bottom and 3 x's on top. I can cancel those 2 with 2 of those, and I just have negative x. Then I come back over here to see the limit as x is approaching positive infinity. So I'm going to put positive infinity in for x there, and I get negative infinity. And so I have negative infinity is my limit. All right, number 9, the limit as x approaches 3. First thing I try to do is plug 3 in, but 3 minus 3 is 0. It causes 0 in the denominator. So I am going to factor, cancel, and then try again. So on the top, I have 2 terms. When there's 2 terms, there's 2 ways to factor. First is, can you pull out a greatest common factor, which we cannot. And the second way is the difference of 2 squares. This is x squared minus 3 squared. So we're going to have x plus 3, x minus 3. And that's over x minus 3. So I'm able to cancel, and it leaves me with x plus 3. So I factored, canceled, now I'm going to try again. So if I plug 3 in now, I'll have 3 plus 3, which is 6. And that is my limit. Number 10, the limit as x approaches 4. I'd like to plug 4 in right now, but if I did, in the denominator, I would have 16 minus 16, which is 0, and that's a problem. So I'm going to factor, cancel, and try again. So in the denominator, I have 2 terms again, so there's only 2 ways to factor. I can pull out a greatest common factor, which I can't, or it's the difference of 2 squares, which it is, x squared minus 4 squared. So that's going to be x plus 4, x minus 4. On top, I have a trinomial. So that one's I'm going to backward FOIL, x and x. This sign right in front of the constant is a plus. That tells me my signs are going to be the same. And if I look over here, it tells me which sign they're going to be. They're both going to be negative. Factors of 12 are going to be 1 and 12, 2 and 6, or 3 and 4. But I know I'm really hoping that I can cancel out one of these. So I'm really hoping one of those is going to be a 4. So if I look at the 3 and the 4, if both of those are negative, that would create negative 7. So that works. And I can cancel that. And now I'm going to plug 4 in to what I have left over. And I have 4 minus 3 over 4 plus 4, which is 1/8. Number 11, we have a piecewise function, and we're looking for the limit. So this first one says, find the limit as x approaches -1 from the right side. So if I look at a number line, and here's -1, this is the right side. These are x values that are greater than -1. So I'm looking for x values that are greater than -1. And so that's going to be right here. X is greater than -1. So I'm going to plug -1 into this middle equation. And I get 5 times -1 plus 2, which is -5 plus 2, which is -3. Part B says, find the limit as x approaches -1 from the left. So here is the left side. And these are x values that are less than -1. So for this one, I want to plug them into the top equation. So if I go to plug -1 into the top equation, there's nowhere to plug it into. And so it's automatically whatever number is right there, which is -3. So the limit as x approaches -1 from the right is -3. The limit as x approaches -1 from the left is -3. Therefore, the limit as x approaches -1 is -3, because coming from the left and right, I got the same thing. And then part D says, Part D says the limit as x approaches 3 from the left. And so I am going to look at a number line here. And so here we have 3, and here is the left of 3. So these are x values that are less than 3. And then I'll come over here and see where that happens. X values less than 3 happen with the middle equation. So I want to plug 3 into that middle equation, and I get 5 times 3 plus 2, which is 15 plus 2, which is 17. Number 12, finding limits on another piecewise function here, says I want to find the limit as x approaches 2 from the right. So here is 2. Here's the right side of 2. Those are x values that are greater than 2. So if I look, that's on top. So I want to plug 2 into the top equation. And if I do that, then I'm going to have 4 minus 2 times 2, which is 4 minus 4, which is 0. That's my limit. Part B says the limit as x approaches 2 from the left side. So this is the left side of 2. Those are x values that are less than 2. And that happens in the second equation, so I need to plug it into the second equation. And I'll get negative 3 times 2, which is negative 6. So that would be my limit. Okay. So number 13 says to find the limit as x approaches negative 1 from the left. Negative 1 from the left. So find negative 1 and picture a vertical line there. And then figure out which side is the left of that. This is the left side of that. And follow the graph. As you get closer and closer to negative 1, your y values are going up, 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 up. So they are going to positive infinity. Number 14 says the limit as x approaches negative 1 from the right. So I still have negative 1 highlighted in yellow there, and this is the right side. As I follow my graph coming from the right, as I get closer and closer to x equals negative 1, my y values are getting closer and closer and closer to 5. So the limit as x approaches negative 1 from the right is 5. Therefore, the limit as x approaches negative 1 does not exist, because coming from the left and the right, I did not equal the same thing. So number 16 says to find the limit as x approaches 2 from the right side. So I'm going to go and find 2 on my graph and kind of look at a vertical line there. And I'm coming toward it from the right side. So here is the right side. So I'm going to follow my graph coming from the right side. As I get closer and closer and closer to x equals 2, my y values get closer and closer to negative 4. This next part says the limit as x approaches 2 from the left. So here is the left side of 2. As I follow my graph, as I get closer and closer to 2, my y values get closer and closer to 4. So coming from the right side, my limit was negative 4. Coming from the left side, my limit was positive 4. Therefore, the limit as x approaches 2 does not exist, because coming from the left and right, I got two different things. The next one says the limit as x approaches negative 3. So here is negative 3. It doesn't say from the left or the right, so I'm going to check them both. Coming from the left, I'm approaching a y value of negative 1. Coming from the right, I'm also approaching a y value of negative 1. So the limit is going to be negative 1. Number 20, the limit as x approaches negative infinity. So here is my number line, and it's going more and more negative as I go that direction. So if I start following my graph going to the left, I ask myself, are my y values going straight up, straight down, or are they leveling off at a particular y value? And these seem to be leveling off around y equals 2. So this limit would be 2. Number 21, the limit as x goes to positive infinity, so as x goes to the right, if I follow my graph to the right, it's going up, 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 up. So that is going toward positive infinity right there. And then numbers 22, 23, and 24, these are not limits anymore. These are asking us to find the y values. So it wants the y value when x is negative 3. So when x is negative 3, look up and down negative 3, and you find a point right there. So the y value is at 2. So g of negative 3 is 2. For g of 2, you look up and down x equals 2, and you'll see a point right there at 4. So g of 2 is 4. And then g of 4, you look up and down x equals 4, and there's no point anywhere. So g of 4 does not exist. Okay. So a reminder, a function is continuous at x equals a if these three things occur. So f of a exists, there's a point there. The limit as x approaches a exists, meaning the limit from the left and the right are the same. And those two equal each other. F of a equals that. So it says, for the graph of g of x above, which it really means to the right, where is the function discontinuous? And based upon the definition, explain why it is discontinuous. So if we look at this graph, reading left to right, the first place we come to where it would be discontinuous is going to be at negative 3. So it's discontinuous at negative 3. When we check three things, f of negative 3, is there a point at negative 3? Yes, it's right there. So that's fine. Then we check, does the limit as we approach negative 3 exist? Coming from the left, coming from the right, we're approaching the same thing. So yes, the limit as x approaches negative 3 exists. In fact, we can say what it is. It is approaching from the left and the right, they're both approaching negative 1. And f of negative 3, which is the point when x is negative 3, that happens at 2. So the problem occurs because these two don't equal each other. So it is discontinuous at x equals negative 3 because f of negative 3, the point, does not equal the limit as x approaches negative 3. That is why it is discontinuous there. The next place on this graph where it would be discontinuous, if I'm reading left to right, would happen at negative 1 here. I would discontinue my ride there. So I'm going to write that it is discontinuous at x equals negative 1 because, and the first thing I check is, does f of negative 1 exist? Is there a point when x is negative 1? And there's not. Looking up and down, there's no point anywhere. So we just stop right there. And that is the reason it is discontinuous there. The next place it's discontinuous would be at 2, right here. And so it's discontinuous at x equals 2. The first thing I would check for discontinuity is the point. Does f of 2 exist? Is there a point when x is 2? And yes, there is. That happens at 4. The next thing I would check is, does the limit exist? So as I approach 2 from the left and from the right, am I approaching the same y value? And no, I'm not. So the limit as x approaches 2 for this function does not exist. That is why it's discontinuous there. And the last place this is discontinuous is going to be over here at 4. So it is discontinuous right there. You'd fall right through the graph. So it is discontinuous at x equals 4. The first thing we would check is, does f of 4 exist? And it fails right away. F of 4 does not exist. So that is why it is discontinuous at 4. Okay. 26 says we have a piecewise function and we want to find where it is discontinuous and also where it is continuous. And we'll do that at the same time here. So the places where it might be discontinuous are where it's being pieced together over here. We have -2 and we have 4. And those are the values we actually want to check on. So we want to see if it's connecting at -2 or connecting at 4. Otherwise, we're just going to assume that it's continuous everywhere from -infinity to +infinity, which has an infinite number of values. There's only 2 we're checking. So we're going to check x equals -2. So I'm going to check the top equation for this, plugging -2 in right there, and I get 3 times -2 plus 6, which is -6 plus 6, which is 0. And then I'm going to plug it into the middle equation. So if I plug -2 into the middle equation, I have -2 squared minus 4, which is 4 minus 4, which is 0. I got the exact same thing when I checked -2. That means everything's okay at -2. It's continuous there. So now I want to check the other possibility, which is going to be at 4. So checking 4. Okay, I want to check x equals 4. And so I want to check the middle equation. If I plug 4 into that middle equation, I'd get 4 squared minus 4, which is 16 minus 4, which is 12. If I put 4 in the bottom equation, I would get 8 plus 4, which is also 12. So I checked 4 and it also is good. So where is it discontinuous? Nowhere. It is actually continuous everywhere, from -infinity to +infinity. Because the only 2 places in question, we checked them and they both worked out. So number 27, same idea. We're going to assume that it's going to be continuous everywhere, from -infinity to +infinity. The only point in question is at 3. So I'm going to check x equals 3. So plugging it into the top equation, there's nowhere to plug it into, so it's just automatically going to be that number, 0. Plugging it into the bottom equation, I'm going to get 2 times 3 squared minus 5 times 3 minus 4. So that's 2 times 9 is 18 minus 15 minus 4. So that is 18 minus 19, which is -1. So I plugged it into the top, I got 0. Plugged it into the bottom, I got -1. Those are not the same. So it is discontinuous at x equals 3. And it's continuous everywhere except 3. So I'm going to pluck 3 out of the number line. And in its place, I will put a little union symbol. And so it's continuous from -infinity to 3. And then again from 3 to infinity.